Welcome to PLC Troubleshooting Tips. Today we're tackling 3 of the most common causes of illogical rung behavior: OTU, JSR, and MCR. These instructions can confuse even seasoned technicians, so let's break them down clearly and visually. We'll look at these 3 scenarios in order of most commonly experienced to least, and at the end, we'll add a couple of bonus gotchas that occasionally trip us up. First up, OTU, the unlatch instruction. This is the number 1 cause of a rung that looks perfectly logical, but refuses to energize. Here, we press the run button. The start and run pilot contacts become true, but the seal in for CR1 does not. That is just not logical. With no seal in, run pilot drops out the moment the start signal disappears. Start by checking the most common culprit, an OTU instruction elsewhere in the program that unlatches CR1. If something is forcing that bit off every scan, your rung will never behave logically. To find it, right-click the CR1 instruction, and then select Go to Cross-Reference. Scan the list for any OTU instructions. In this example, we find an OTU inside the Command Center subroutine. Right-click it and select Go to Location. And there it is, an unconditional OTU turning CR1 off every scan cycle. Mystery solved. Next, JSR, jump to subroutine. If a subroutine isn't being scanned, none of its logic will execute, even if everything inside looks perfect. We begin with a rung that isn't true because the CC_OK bit is false. Using standard troubleshooting, we right-click CC_OK and select Go to Cross-Reference. We see 2 instructions that could energize it, a MOV and an OTE. The OTE is the most common energizer, so we jump to its location in the Command Central subroutine. The output rung isn't true because the all-clear bit is false. We try toggling it on, but it doesn't change. That is just not logical. This usually means one of 2 things. Either something else is forcing the bit off, or the subroutine itself is not being scanned. Most subroutines are scanned via JSR instructions in LAD2, the main routine. So we go there and look for the JSR. Aha! It's not being jumped to because the access granted bit is false. Since we know external network access is down, we temporarily toggle access granted on. Now the subroutine is being scanned. We return to the subroutine, toggle all clear on, and CC_OK becomes true. Back in main, the run pilot output and CR1 and its seal in behave normally again. Troubleshooting JSR issues is straightforward once you know the pattern. 1. Cross-reference the bit that's not behaving. 2. Look for OTE, OTU, OTL, MOV, and CLR instructions. 3. Check whether any of those are inside subroutines. 4. Verify that the JSR conditions for those subroutines are true. Finally, the MCR, Master Control Reset. It's less common, but when it causes trouble, it can be very confusing. The MCR instruction requires 2 rungs, a conditional MCR rung that opens the MCR zone, followed by the rungs you want disabled if that condition is false, and finally, an unconditional MCR rung that closes the zone. The rung is true, but the output is not true? That is just not logical. To check whether an MCR is the culprit, scroll upward in the subroutine and look for an MCR output instruction above the illogical rung. If that conditional MCR rung is false, toggle its controlling bit in the simulator. Once MCR becomes true, all rungs inside the zone behave normally. As shown here, using the PLC Logix 5000 PLC training simulator. A few bonus troubleshooting tips from plc-training.org. Best practices. When first opening a PLC program, and every time you go online, check the PLC status area. Verify online versus offline status. Check whether any forces are active. Sometimes rungs appear frozen simply because you're offline. Other times, a forced bit is causing the illogical behavior. Thanks for watching PLC Troubleshooting Tips, OTU, JSR, and MCR. Please like and share with your students and colleagues. Use the comments below to share your own troubleshooting gotchas. And as always, enjoy your PLC troubleshooting success.
First, please subscribe on the left. Next, continue your learning with our self-study course, and make sure to check out the simulator used in this video.